Hello, today we're going to be looking at solving systems of equations using substitution. Now, when you're trying to solve an equation, if there are two variables, you can't do it. You have to get rid of one somehow. And so substitution is one of the ways that we can get rid of one of the variables. We figure out what the other one is, and then we can go back and figure out what the one we got rid of was. Okay, so when you have two equations, if one of them's already solved for a variable, like this one's already solved for y, that means y equals this. I can just substitute that in for y. So if I replace y with 4x, because it says y equals 4x, now I'm down to one single variable. And if I'm down to one single variable, that means I can easily find the answer. I can combine like terms, so x plus 4x, that's going to be 5x, because if I have one xylophone plus 4 xylophones is 5 xylophones. And once I get to this point, you just divide by 5, so x equals 1. Now that I know that x equals 1, I can go back to one of my original equations and substitute 1 in for x. 1 times 4 is 4, so y should be 4. My solution should be 1, 4. Okay, so when you're taking a look at that, I can double check here by substituting in x is 1 and y is 4. And in fact, 1 plus 4 is 5. That checks out, so I know I did it correctly. The solution to this system is 1, 4. Okay, so let's look at another example. Again, if I already have an equation that's solved for a particular variable, it's very easy. If I need to, I can always solve for a variable in order to be able to use the substitution method. But this way gives you a very accurate picture of what's going on. Okay, so in this case, again, I've already got one solved for y. So I'm just going to replace y here with what it tells me to. And what it tells me to is x minus 1. So x plus x minus 1 equals 3. Well, I don't have to distribute anything, so really it's just x plus x minus 1. One xylophone plus another xylophone is 2 xylophones. I'm going to get rid of the 1. So 2x equals 4, divide by 2, and x is going to come out to 2. Okay, so once I have that value, I can substitute it back in. 2 minus 1, so I'm putting in 2 for x because that's what I found x was. So y should equal 1. I can check, does 2 plus 1 in fact equal 3 if I substitute in the y and the x? It does. So my solution is 2, 1. Again, substituting in what it tells you to from one equation into the other, so we get down to one variable. That's really important. And once we have one variable, we can combine like terms and solve the equation and find the missing value. Okay, so let's look at another example. Okay, I've got 2x minus 3y equals 21, and y equals 3 minus x. Okay, again, I've already got one equation solved for a variable, so I'm going to substitute in for y. This is where you need to be cautious because there's a coefficient, so you are going to have to distribute. Okay. Now, here's my suggestion. I like, when I'm distributing something like this, to change this, any of the subtraction, to plus a negative, because then you're way less likely to mess up the negative signs. So I would change this to plus negative 3 times 3 plus negative x equals 21. And then I would distribute. This way, you're way less likely to mess up the negative signs. Okay, so 2x doesn't do anything. I'm distributing the negative 3, so negative 3 times positive 3 is negative 9. Negative 3 times negative x would be positive 3x equals 21. Now, because I have it all as addition, I can just combine like terms using the commutative property. So 2x plus 3x is 5x plus negative 9 equals 21, or you can go back to minus 9 at this point. I'm going to add 9 to both sides. So you get 5x equals 30. dividing by 5, so x should be 6. Okay, and again, I can substitute that back in and see if it works. If I substitute it back in here, that would be y equals 3 minus 6. So y would be negative 3. So let's check. 2 times 6 minus 3 times negative 3. Does that equal 21? That would be 12 minus this, again, plus the negative. A negative times a negative is a positive, so that's plus 9. And it does, in fact, equal 21, so that is my solution set. So x is 6 and y is negative 3. Again, I'm using one to substitute in the other to get down to one variable, and once you go through it, you can eliminate everything so that you can find what that missing value is, and then you can use that number to substitute back in order to find the other one. All right, let's say I had something like this instead. Okay, I do not have an equation that is solved for a variable already. So I have to solve one of them for the variable in order to be able to use substitution. So if I take this first one, the x has a coefficient of 1. So the easiest thing I could do is add 5y to both sides so that x is by itself. And once I have x by itself, then I'm going to be able to substitute it in. So I'm going to add 5y. Now, would you still get the same answer if you solve for y and substitute it in? Sure. It's just going to be more work. So I'm always kind of like, hey, this will be the simplest thing. Let's do that. Okay, so x equals, this cancels. You get 10 plus 5y. Now I can substitute it in for x in my other equation. Make sure you don't substitute it back into the one you just solved for. That's not going to work out well. So substituting it back in here. I'm going to go ahead and change that to plus a negative because it just allows me, again, to use the commutative property to add things up and change the order. 2 times 20, I'm going to distribute. 2 times 10 is 20, plus 2 times 5y is 10y, plus negative 10y equals 20. 10y plus negative 10y is nothing. And so I end up with 20 equals 20. What just happened? What's going on? Well, this is a case of infinitely many solutions. These, in fact, are the same line. So if you have the same line, that means it's one over the top of each other, and there's an infinitely many number of solutions. If you get down to an answer of something like a number equaling itself, that's infinitely many. If I was doing something and I got a weird answer like, 10 equals 5, well, that's not true in any universe that you know. This would be no solution. So if you get the variables all to cancel and you get two numbers that are different to each other equal, that's no solution. If you get the same number equal to itself, that's infinitely many. And let me go back and show you why, and just looking at this, you can tell that they are, in fact, the same line. Okay? If I were, because I get to do this with equations, if I were to take this equation, the x minus 5y equals 10, and I doubled everything in the equation. 2 times x is 2x. 2 times minus 5 is minus 10y. 2 times 10 is 20. You can see that this now matches that. And so again, it shows you that it's in fact the same line. So if you are solving it and you get something weird like 20 equals 20, that means infinitely many solutions. If you get two numbers equal to each other, all the variables are gone and they're not equal to each other, then that means there's no solution. Okay? I hope this helps, and if you have questions, you know where to find me.